what is the value of k? Given that you have k to the power of 6 equals 2 to the power of 6. So from here, we have k to the power of 6 minus 2 to the power of 6 equals 0. So let's resimplify this 6 and 6. We can have it here to be k to the power of 3 and parentheses to the power of 2 minus 2 to the power of 3 and parentheses to the power of 2 equals 0. So recall that when we have a square minus b square equals as when we have a plus b and parentheses multiplied by a minus b and parentheses. So here will be k to the power of 3 plus 2 to the power of 3 in parentheses multiplied by k to the power of 3 minus 2 to the power of 3, then equals 0. So from here, for this expression to be equal 0, it's either we have k to the power of 3 plus 2 to the power of 3 equals 0, or we have the second, k to the power of 3 minus 2 to the power of 3 equals 0. So let's say case 1. We have k to the power of 3 plus 2 to the power of 3 equals 0. We have a to the power of 3 plus b to the power of 3. This equals as a plus b multiplied by a square minus ab plus b square. So definitely from here, our a is k, our b is 2. So we have our a to be equals k, then our b to be equals 2. Then from here, we are going to have k plus 2. Then this will be k square minus a, k, b is 2. Here will be 2k plus 2 square equals 0. So from here, we are going to have this to be k plus 2 multiplied by k square minus 2k plus 4. Then everything equals 0. Likewise, again, for this expression to be equal 0, it's either we have k plus 2 equals 0, or we have k squared minus 2k plus 4 to be equal 0. So from here, we have the first k to be k equals minus 2. This is our real solution. While this also, we can find the possible value of k by using quadratic formula, where we are going to have k equals minus b, then positive or negative, then root of b squared minus 4ac divided by 2a. While the parameter a, this and this is the coefficient of k squared, which equals 1, and b, the coefficient of k, which is minus 2, and c equals 4. So when we plug in everything here, we are going to have k to be equals minus outside minus 2 in parentheses, then positive or negative square root of minus 2 in parentheses to the power of 2. 4 multiplied by a is 1, multiplied by c is 4. Then all divided by 2 into 1. So from here, we have k to be equals plus 2, positive or negative, root of this to the power of 2 will give us 4. From here, we give us 16, all divided by 2. So we have k to be equals 2, positive or negative, root of 4 minus 16 will give us minus 12, then divided by 2. So from here we have k to be equals 2, positive or negative, root of 12 multiplied by root of minus 1 divided by 2. So we have k to be equals 2, positive or negative. We can have 12 to be simplified as 4 times 3, then times root of minus 1 divided by 2. So we have k to be equals 2, positive or negative, root 4 will give us 2, root 3. Then root of minus 1 equals I. Definitely here will be I. all divided by 2. So we have here to be k equals 2 divided by 2. This 2 divided by this, positive or negative, 2 multiplied by root 3I divided by 2. So we have k to be equals 2 divided by 2 will give us 1, positive or negative. This divided by this will give us 1, multiplied by root 3I, here will be root 3I. This happens to be the second solution, but this is a complex solution. So yk equals minus 2 is our real solution. Then let us recall from second case where we have k to the power of 3 minus 2 to the power of 3 equals 0. Then let us recall that when we have a to the power of 3 minus 2 to the power of 3 can be simplified as a minus b in parentheses, again multiplied by a square plus ab plus b square, all in parentheses as this. So where we have a to be equals k, then b to be equals 2. So we are going to have from here to be k minus 2 in parentheses multiplied by k square plus 2k plus 2 to the power of 2, then equals 0. So we have k minus 2 multiplied by k square plus 2k plus 4, then equals 0. Then for this expression again to be equals 0 is either we have k minus 2 equals 0, or we have k square plus 2k plus 4 equals 0. So from here we have another k to be equals to the second real solution. Then from here we can also get k from quadratic formula where we have k to be equals to minus b, positive or negative, square root of b square minus 4ac divided by 2a, where we are going to have parameter a to be the coefficient of k square, which is 1, parameter b to be the coefficient of k, which is 2, parameter c equals 4. Then when you substitute everything here, we are going to have k to be equals, here is 2, here is minus b, here will be minus 2, positive or negative, root of 2 square minus 4 times 1, which is divided by 2. So from here we have k to be equals minus 2, positive or negative, root of 2 square will give us 4. 4 times 1 is 4 times 4 will give us 16, divided by 2. So we have k to be equals minus 2, positive or negative, root of minus 12 divided by 2. We have k to be equals minus 2, positive or negative, root of 12 times minus 1 divided by 2. Then we have k to be equals minus 2, positive or negative, root 12 multiplied by root of minus 1 divided by 2. So we have k to be equals minus 2, positive or negative, root of 4 times 3 multiplied by minus 1, all divided by 2. So we have k to be equals minus 2, positive or negative, root 4 will give us 2, root 3, root of minus 1 equals I. So here will be I divided by 2. So dividing through by 2, simply here will be minus 2 divided by 2, positive or negative 2, multiplied by root 3I divided by 2. So we have k to be equals minus 1, positive or negative, root 3I. Likewise, we also have k to be equals 2 for this. This is a complex solution, while this is a real solution. Then let us also record that we have k to be equals 1, positive or negative, root 3I, and k equals minus 2. These two solutions are real solutions, while these two solutions are complex solutions. So if you are new and find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more math tutorial videos.